All right, everybody, we are now shooting the third video for the Unit 2 Pythagorean Theorem lessons. We've done the concept, we've done the application. Feel free to go back and watch the first video if you need to understand the global concept of Pythagorean Theorem and the formula. Number 2, the application, we specifically focused on finding missing sides in right triangles. For this one, we're going to see if we can use the Pythagorean Theorem for a different sort of application where we can classify triangles. And you might recall that there are really only 3 types of triangles, although we can name them lots of different ways. But one of the ways to classify triangles is by angle. And when we're classifying by angle, there are 3 different options. There are, and I have them written in a variety of different places. There's the acute triangle, where all the angles are acute. There's the right triangle, where one of the angles is right, indicated with a little marker in the corner. And an obtuse triangle, where one of the angles is obtuse, or greater than 90 degrees. So once again, acute, right, or obtuse in this order. Now, we should be able to, if we've done this correctly, use the Pythagorean theorem to actually identify what type of triangle we're dealing with. And what I want you to identify is this. If we look for the first one, and while I'm going to run out of space, I'm not going to draw my squares off of each side. What you might imagine is, since A and B and C are also similar to one another, it's a little hard for us to identify, first of all, what the angle C would be, or the side C, because we don't have that hypotenuse across from the 90-degree angle because there's no 90-degree angle. So I kind of just randomly assigned A, B, and C, hoping the C was the longest one. But if I drew a square off of A and a square off of B and a square off of C, I think we'd be hard-pressed to say that A and B together make C, which to me means C is too small. So if you see a triangle like this one, where C is too small, if C is too small, then the triangle is acute. It's very simple. So if the C is too small, the triangle is acute. It reminds me because acute triangles are smaller than 90. So C is too small, the triangle is acute. To me, that makes sense. Now on the other extreme, if I have a C value that is too large, once again, C is supposed to be the side across from the 90-degree angle. And we don't have a 90-degree angle, but we did try to arrange it roughly, smallest to biggest. And I don't know if we nailed it exactly, but I hope I got the biggest one as C. I sure think I did that. So in this one, if I drew a square off of here and a square off of here, but a giant square off of side C, the C in this case appears to be too big. So once again, sticking with the same theme, if the C is too small, then the triangle is acute. But if the C is too big, as it appears to be here, I might talk about how the angle is opened up too much. This angle is more open than it should be, meaning it's bigger than 90 degrees. So if C is too big, the angle is big. The triangle is big, it's obtuse. So C is too big, the triangle is obtuse. And then of course, like the 3 little bears, the one that's just right is the one that we're normally after. So if the C is just right, if the C is exactly the size it's supposed to be, that means it's the size of A and the size of B combined, which is exactly what the theorem says, then the triangle is a right triangle. So one more time, if C is too small, the triangle is acute. If the C is too big, the triangle is obtuse. And if the C is just right, then there's no pun intended here, then the triangle is right. Now, because this doesn't seem to have a great application, I made 2 examples. We'll look at them both, and this video will be done. So look at the first one. I give you 3 side lengths, and I ask, is this triangle, without drawing it or sketching it or with no paper or picture whatsoever, is it acute, obtuse, or right? Now here's what I'll do. In this problem, I can easily determine that this is the smallest side and this is the biggest side. So even though I don't have a drawing, I'm going to go ahead and put A, B, and C. I guess I could have kept C red to be consistent with the other videos, but I think we can manage this. And we know that our formula is A squared plus B squared equals C squared. So A is 4 because that was the smallest side because it's the smallest number. So 4 squared, which becomes 16. And 5 is the middle because it's not the biggest or the smallest. So 5 squared is 25, and we're going to add those together, and we're going to get 25 and 35 is 41. And C squared is 6. So 6 squared is supposed to be 36. Now here's what I want you to observe. The C is supposed to be 36, but when I do my other 2 numbers, it's 41. That means this number is too small. It's not big enough to meet the pattern that we need. It's too small. And if the angles are too small, then the triangle, that's my symbol, triangle is acute. Okay, that's what I took from the previous slide, looked like this one. If C is too small, then the triangle is acute. Very simple. Now, you could probably imagine we're going to look at a different one, but the reason I bring this one up is because it's not always apparent as to what the side lengths are. So a couple things you can do. You can always estimate, but there's no real reason to do that sometimes. Since up here I assigned A, B, and C, I might have a hard time assigning what A, B, and C are. Instead of doing that right off the bat, I'm just going to square everything right off the bat. Now 3.4 times 3.4, I'm actually going to do that off to the side. You could do the same thing, carry the 1. 6, 5, 1, 1, and I get 1156. So 3.4 squared is 1156. 19 inside of a square root, but then being squared, interestingly, this square and this square root are opposites of one another, so they cancel out. So this just ends up being 19. That's really easy math. And 6 squared is 36. We know that one. So now I might not have known my original 3 blue values, but I can see from this that this must have been A, this must have been B because of the way the numbers increase, and this must be C. So here we go. If the formula is A squared plus B squared equals C squared, and it always is, and A squared was 1156, we already did the hard work there, and B squared, the square and the square root canceled out, and we get 19, and C squared, 6 squared was 36, then here's what we have. 11 plus 19 is 30 with the decimal 0.56 on the end. And what you'll notice is this. Look, I get 30.56. This number here is too big for our pattern. Too big means obtuse. Okay, so we have an obtuse triangle. And that's really it. So that is how you classify triangles using 3 sides and the Pythagorean theorem. One last time. If C is too small, the triangle is acute. If the C is too big, it's obtuse. And if it's just right, then it is just right. So good luck classifying triangles.